Welcome again to Pre-Calculus 12. We're looking at trigonometric functions, a review of what you learned last year. Last time we talked about sine and cosine and tangent. And we're going to add the reciprocal trig functions today. So you can fill in on your paper that sine from SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now we're introducing some new ratios that don't exist on your calculator, and those are cosecant, secant, and cotangent. So basically cosecant goes with sine. They are reciprocals of one another. You might have remembered the word reciprocal from dividing fractions. To divide a fraction, you multiply by the reciprocal. Reciprocal just means you change the numerator and denominator. So cosecant is the same as sine. Instead of opposite over hypotenuse, it's hypotenuse over opposite. Secant is the reciprocal of cosine. And cotangent, there's a typo here, should be COT. Cotangent is the reciprocal of tangent, adjacent over opposite. So we have another acronym now. Cho, sha, cow. Sounds Chinese. There isn't actually an acronym for these ones.
No.
Okay. Now if we put these ratios onto the angle and standard position on a coordinate grid, then we can relate the opposite hypotenuse and adjacent to a coordinate point and the radius of a circle. So anytime that you have a point in standard position, you can make a triangle with that point using the nearest x-axis. The x-coordinate of that point will be the distance to the base of the triangle. The y-coordinate of the point will be the height of the triangle, and the radius is the length of the terminal arm. So if my angle is theta, the sine is opposite over hypotenuse, which in this case would be y over r. Opposite and hypotenuse. So here, opposite is represented by the y-coordinate, hypotenuse is represented by the radius, and the adjacent side is represented by the x-coordinate. So we talked about this last time, how if the radius is 1, then sine is just the y value, and cosine is just the x value. Tangent is y over x, and cosecant, secant, and cotangent, again a typo there, cotangent, they're just the reciprocals. Cosecant is r over y, secant is r over x, and cotangent is x over y. You should know these by the back, like the back of your hand, by the time we finish with trigonometry. Now, because of the Pythagorean theorem, because a squared plus b squared equals c squared, that means x squared plus y squared is r squared. So r is the root of x squared plus y squared. And the radius is always positive. You can't have a negative radius of a circle. The radius of a circle is always positive. Now the x-coordinate and the y-coordinate could be positive or negative. So for example, on this diagram here, the x-coordinate is negative because we're on the negative part of the x-axis. And the y-coordinate is positive. Any questions so far? Okay, page 2. Again, a little review from last year. The CAST rule, or all students take calculus. All students take calculus. Or if you start in quadrant 4 and go around counterclockwise, you have CAST. Now in quadrant number 1, x is positive and y is positive. So what that means is that x over y is going to be positive, y over r, everything's going to be positive. So sine will be positive, tan will be positive, and cosine will be positive. In quadrant number 2, if we have an angle theta, that takes us into quadrant number 2. To make a triangle in quadrant number 2, you go from the terminal arm to the nearest x-axis. So the y-coordinate is still positive, but here the x-coordinate is negative. We're on the negative side of the x-axis. So that means anything that has x in it is going to be negative. So let's see. Cosine is x over r. So since r is always positive, cosine here will be negative. Tangent is y over x, which is a positive over a negative. So the answer is negative. And sine is y over r, which is a positive over a positive. So the result is positive. Negative over positive. In quadrant number 3, if we have an angle down here, then y is below the x-axis and x is to the left. Both the x and the y's are negative. So that means sine is going to be negative over positive, which will give a negative result. Cosine will be negative over positive, which gives a negative result. And tangent is negative over negative. Negative divided by negative is positive. So tangent will be positive in quadrant 3. And in the very last quadrant, only the x-coordinate is positive, but y is not. So sine will be a negative value because the y-coordinate is negative. And cosine will be a positive value because the x-coordinate is positive. Tangent will be a negative over positive. So in total, it'll have a negative result. So this is where the CAST rule comes from. In quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cosine is positive. And in quadrant number 1, all of them are positive. So we have all students take calculus. Now what about cosecant? Where is cosecant positive? Let's check. What is cosecant?
Oh, nailed it. Okay. Well.
Where is cosecant positive? The same as sine. Because sine and cosecant are just reciprocals. So if sine is positive, then the reciprocal of that number will also be positive. So cosecant is positive in the same places as sine. You can write that into your table. Secant is positive in the same places as cosine. And cotangent is positive in the same places as tangent. Now, I always had trouble in high school remembering that sine and cosecant are reciprocals, because sine starts with an S and cosecant starts with a C. I always thought that sine should go with secant. They both start with S. And cosine should go with cosecant because they both start with co. But just remember that it's opposite. S goes with C, C goes with S. And then cotangent and tangent are the only ones that both have T's. So let's do some examples. In which quadrant is sine negative and tangent positive? So let's see, where is sine negative? All students take calculus. So that means all are positive in 1. Sine is positive in 2. Sine is negative in 3. And sine is negative in 4. It's my hand. Tan is positive, where all are positive, or T. So the quadrant where both of them happen is quadrant 1, 2, 3. Okay, we can also find all the trig ratios given just one of the trig ratios, since there's so many relationships between x, y, and r. So if we're given that cosecant is negative 1.5, if we write that as a fraction, then we can find the other ratios. So negative 1.5, you guys know what that is as a fraction, right? If you're not sure, you just put negative 1.5, change to fraction, and it's negative 3 over 2. And looking on the first page, cosecant is the same as r over y. So this should be r over y. Now the number negative 3 over 2 can actually be written in 3 different ways. And that negative sign doesn't have to go at the front. It could go with the 3. Or it can go with the 2. And those all mean negative 1.5. So we basically have to figure out what is r and what is y. Okay, so in this sense, r is the number 3 and y is the number 2. And we just have to figure out which one has to be negative. Why is it y? R is always positive. R can never be negative. So that means that the y must be negative. That means we're thinking about that fraction like this one. Anybody know what x is? Yeah, we can use a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So we just plug in our values. x squared plus 4 equals 9. So x squared equals 5. X is root 5. Now, I purposefully made a mistake going from here to here. Yeah, I've got to include the positive or negative when I take a square root on both sides. Okay, so that means that x is root 5 or negative root 5. I'm not sure yet. And that's the reason why they gave me this extra piece of information here. This little bit of information will help me to choose whether I need positive root 5 or negative root 5. So it says 10 is less than 0. So that'll tell me which quadrant I'm in. All students take calculus. 10 is less than 0 in quadrants 4 and 2. Okay, that doesn't help. Anything else I could use to help me know which quadrant I'm in? How do you know it's in quadrant 4? Because the y is negative. Cosecant. Cosecant is negative when sine is negative. Sine is negative in quadrants 3 and 4. So because the y value is negative, that means I must be in quadrant 4. And in quadrant 4, x is positive, because I'm on the positive side of the x-axis. So that means I must have this one and not this one. So now I can finally answer the question, what is cosine of A? So cosine of A is, from my first page, x over r. And now that I've calculated x to be square root of 5, I know my r is 3. That's all I have to do. I don't actually have to find out what the angle is. I just need to find out the ratio. Are there any questions? Okay, so that's quite a number of steps. But based on the information that they give, you can actually find out which quadrant you're in. So there's a similar example on the next page, example number 3. So see if you can take this apart. Find out what the x value is, what the y value is, which quadrant it's in, and can you find out what cotangent is. Same steps as the previous problem. So first start with what you're given. We're given that sine A is 2 over 5, and from the first page, sine is y over r. R always has to be positive, so that means r must be positive 5, which means that y has to be 2. Now using x squared plus y squared equals r squared, I can find the x value. X plus 2 squared is 5 squared. So x squared is 25 minus 4, or 21. So if I take the square root on both sides, I have positive root 21 or negative root 21. So now I have to use my other pieces of information. It tells me that cosine is negative. So using all students take calculus, I know I have to be in quadrants 2 or 3. I can also use the fact that sine is positive to know that I have to be in quadrants 1 or 2. So where those overlap is in quadrant 2. And in quadrant 2, x is negative, y is positive. So now I know that I am looking at a negative x value. So now I can figure out what cotangent A is. Cotangent A from the first page is x over y, which is negative root 21 over 2. The answer is negative, which is great because I know that cotangent should be negative in quadrant 2. Are there any questions? Okay, so that triangle looks like it has a radius of 5. So the length is 5. It has a y-coordinate of 2, and the x value is negative root 21. So that's what the triangle looks like. If you found that angle backwards, you'd be able to get the angle inside the triangle. And we can continue along the same vein. If we know cotangent A is negative 2 over 3, yeah, we don't actually know how this is written, because it's possible that it could be negative 2 over 3, or it could be 2 over negative 3. Both of these are negative 0.66666. Cotangent is x over y. The trouble with that is that neither of them is r. So that means neither of them has to be positive. So x could be negative 2 and y could be 3, or x could be 2 and y could be negative 3. Luckily, in both these situations, r is the same value. R is the square root of x squared plus y squared, which is 4 plus 9. Even if I have a negative sign, it still gives me the same result for r. 4 plus 9 is 13. And it has to be positive. So to determine secant A, from the first page, secant is the opposite of, it's the reciprocal of cosine, so it's r over x. So it's root 13 over negative 2. Or root 13 over positive 2. I don't know. I need one more piece of information if I'm going to know which quadrant it's in. So this one actually has two different answers. They would have to tell me sine is positive, or something. I just need a little bit more information in order to be able to find out which quadrant that secant is in. Does that make sense? Cool. Now, given a coordinate point, we can find all the 6 trig functions. This is like your homework from last class. So given a coordinate point, that's the point x is 2, y is negative 1. So that's down here in quadrant 4. So this is the x value. This is the y value. And based on that information, we can find all the trig ratios. For example, tangent is really easy. Tangent of A is y over x. So it's just negative 1 over 2. There's another one that's really easy as well. Cotangent, because cotangent's just the reciprocal of tangent. Yeah, that's the best way to write it. You can just write this as negative 2. I like writing it as fractions just to help me remembering that, you know, it actually, the 2 actually does represent the x value, the negative 1 does represent the y value. Now, to find sine and cosine, I need to do a calculation. So I can draw this triangle on a coordinate grid. X is 2, y is negative 1. So the r value is just going to be 2 squared plus 1 squared. And it has to be positive. So sine is y over r, aka negative 1 over root 5. And in grade 10 you had to rationalize the denominator. I don't care if you rationalize the denominator or not. You can leave it in this form. Cosine is x over r, so 2 over root 5. And cosine matches secant, because the c's go with the s's, and the s's go with the c's. There's my 6 trig ratios. Yeah, we're doubling everything you need to know. X is the adjacent side, and y is the opposite side. And r is always the hypotenuse, and the hypotenuse is always positive. We can also determine the sine and cosine of angle in standard position if we're given the terminal arm as an equation. So 2x plus 5y equals 0 is the equation for a line. If we want to find out what that line is, we can solve that for y. So we're just going to put y on one side by moving the 2x to the other side and then dividing both sides by 5 to get y equals negative 2 over 5x. So this is a line that has a slope of negative 2 over 5. So it goes from the origin down to over 5 and up to left 5. It gives us a little bit of extra information, which is that x is less than 0. So x is negative. That means we're looking on this part of the x-axis. So my terminal arm must be this part right here. So now I can make my triangle 5, 2, and I can determine the radius. So r is the square root of 5 squared plus 2 squared. 25 and 4 is 29. Which of those two values is negative on my triangle? The 5. I'm on the negative part of the x-axis. So now I can find sine and cosine, and I could treat it just like I did any triangle from grade 10. There's my angle. The sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. So the adjacent is always the x value, the opposite is always the y value. So sine of the angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And that's it. So we have one last example, and that is determining a point a certain number of units away from the origin. And this is extra challenging. Luckily, we're given some information to start, so we can start with what we're given. We know the tangent value. And tangent is y over x. So that means that y is 3 and x is 4. But there's a problem. We're supposed to be in quadrant 3. And in quadrant 3, x is negative. So do you know another way that you could write 3 over 4? Negative 3 over negative 4 also gives positive 0.75. So if we're in quadrant 3, that means that the y value has to be negative and the x value has to be negative. And when you divide those two, you still get a positive answer for tangent. Okay, so when you see 3 over 4, it could be 3 over 4, it could be negative 3 over negative 4. So I can draw that triangle. Its a y value is negative 3, and the x value is negative 4. So that looks like this. And now it's asking me to find a point that is 8 units from the origin. So the origin is just my 0, 0 point. And I have a distance of 3 in the y-axis, 4 in the x-axis, and I want to know, on this terminal arm, where is the point that is a total distance of 8 units away? So I want this distance here to be 8. And I want to find out what coordinate point that is. So what is the x and the y coordinates at that point? Do you know how far away this green point is from the origin? Let's figure out the radius for the green triangle. It's 5. It's the square root of x squared plus y squared. This is one of those special triangles. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So the radius is 5. So right now, that green point is 5 away from the origin. And I want it to be 8 away from the origin. So I have to take that triangle, green triangle, I have to make it bigger. How many times bigger? 1.6 times. How do you get that? I want to turn 5 into 8. So if I take 5 and multiply it by 8 over 5, I get 8. So if I go from here to here, all I have to do is times 8 over 5. So that means if I want to go from the green triangle, I should really write that 4 in green. On the green triangle, I have a distance of 4. If I want to see how big that is on the red triangle, I just have to take that 4 and multiply by 8 over 5. So that would be negative 32 over 5. So my x-coordinate is negative 32 over 5. And same thing for the y. If I want to take this 3 on the green triangle and make it 1.6 times bigger, just multiply by 8 over 5 to get negative 24 over 5. And that gives me the y-coordinate on the red triangle. So I just took that triangle and made it 1.6 times bigger to make the radius 8 instead of 5. And your homework for today is question number 2 to 8 and 11.